Hello everyone. In the previous video, I already discussed about the introduction for stochastic fundamental analysis or SFA. And today I would like to continue how to estimating technical efficiency using STATA. In this case, I use the cross-section data. What is the cross-section data? The cross-section data refer to data collected from a group of subjects at the single point in time. This is for example. And then another one is time series data. What is time series data? Time series data is data collected from a single subject over multiple points in time. This one, the time series data. And the panel data is combination both cross-section and time series. I would like to remind again about the technical efficiency. Technical efficiency means actual output from given input divided by maximum potential output from given input or frontier. And remind again about the formula. This is the formula, the technical efficiency using the Douglas. This one is deterministic component, this one the noise, and this one the inefficiency term. There are model in SFA, the cross-section and the panel data. And the both there are half normal, truncated normal, exponential, and gamma. And for panel there are two types, time invariant and time varying. This one summarized from the both model, the cross-section and the panel data. The cross-section data, this is half normal, exponential, truncated normal, and gamma. This is the model, and this is the maximum likelihood. And this is for panel data. There are some model here. Maybe in the next video I would like to discuss the panel data model and how to running technical efficiency in STATA, especially for the cross-section data. The first is we should be install the SFA module in our STATA, and then we prepare our data and import to the STATA, and then we run the regression model, and then we run the SFA model, and then we test the hypothesis the inefficiency exists in our model or not exists in there. And then if the inefficiency exists in our data, then we calculate the efficiency score for each subject or each DMU. Okay, right now I will go to in our program. I would like to practice how to calculate the SFA in data, especially in the cross-section data. Okay, before I go here, I would like to inform about our data. Okay, for first, we should prepare the data. This is our data. The data is from the rice production. This is the land yield. This is the land area. This is the land seed used in quantity, and this is land the nitrogen fertilizer. This is land the phosphate fertilizer, and the land labor used, and this one the land the age of farmer, and this one the land the education, and this is land the experience. Okay, we go. And then I use in here 76 farmers in the rice production. And the first stage is we should install the SFA module. Help, and then we should type stochastic frontier analysis. Okay, we find the software in This, in our practice, I use the Federico Piloti here. So we click here and click install here. Okay. And then we import the data, Excel spreadsheet, and first and open data and the sheet 2. And from the first row, as a variable name that is here. Okay, the data already in here. And then we should run the regression model. So regress the field become the dependent, then the independent. Okay, this is the output field, and land, seed, fertilizer, labor is input, it is output. And then the age, education, experience is the external factor that influence the efficiency level. And the first we regress the output as dependent and input as independent, sorry, and then enter. And then we save the likelihood function, the scalar, then likelihood OLS. To you can save another name, but here I just likelihood ordinary least square to indicate this one, the OLS model, equal the estimate likelihood, enter. And then we run the SFA model. SF cross output, input. Okay, for the distribution we use the most simple model, half normal model. Enter. And we save the likelihood function, the likelihood value, I mean scalar, likelihood, half normal, limit, likelihood. Okay, enter. Then I try to run another model. I want to run the truncate model, same as across, and then output, and then input 1, input 2, input 3, input 4, and input 5. And then the distribution, truncate normal, the end, enter. Okay. And then we try to save again likelihood for truncate normal equal, and then try another model, across, output, then input 1, input 2, input 3, input 4, input 5. Distribution model. But in this model, I would like to try use the external factor that possible influence the mechanical efficiency. Type in learn age, learn education, and learn experience. And then we save scalar. external X. Here, after we run LSR and run the regression model and then run the SFA model, we can compare the model to test the hypothesis. The inefficiency is exists or not. So even then, because we want to get the base model, and then if the inefficiency in here, and then we want to compare the submodel, the half normal, we try compare to target normal, and then we compare again to the target normal with the external vectors, and we choose the base model from this data. Okay. Display means to likelihood of OLS. Remember again the formula for the LR test, and to hypothesis test we use the LR test. So -2 divided by likelihood for the construct model minus likelihood for the another one. For half normal. Okay. Compare with the table. Okay, we choose the odd and pound table to test the hypothesis. This is for the critical value, because we try to compare model that with different parameter, because in the regression model we not concerned about the efficiency, as concerned on the error, but in the stochastic frontal model we concerned about the error and inefficiency. So we use the odd and pound model table. We compare here, because the different parameter only one, so the degree of freedom 1. We take percent is 2.706. We compare with this result 18.87. The LR test is bigger than the critical value. It means in our model, in our data have the inefficiency, so the model is accepted. We check the null hypothesis. Which the null hypothesis size there is no inefficiency. The alternative hypothesis side there is the inefficiency. So because the LR test is greater than the critical value, so we should reject the null hypothesis and accept the alternative hypothesis. It means in our data have the inefficiency in the price protection. And then we try compare between the half normal and target normal. Okay, display S2 LL half normal minus LL target normal. Enter. Okay. The result is 0.07, and the result, okay, because this is similar in the half normal and target normal, is care upon the inefficiency, so we use the standard S-square. Okay, because the different parameter is 1 here, 1, then 5% is 3.841. We can see the LR test is less than the critical value, so there is no difference between the half normal and target normal. So we choose the half normal. The half normal is better because there is no difference, but the model is simple than more simple than the rather than the target normal. And then we want to try the half normal with the target normal with the external factors. Okay. Display -2 multiplied by likelihood half normal minus log likelihood x. Wow, the LRS is very big here, 106, and we can check again in the square. And for the degree of freedom is, we can see here 1, 2, 3, 3, and then because this is the target normal is +1, so 4. We can check here. Oh, sorry. Check here for 5% is 9.488, and here the this is 106.34.862. So because the LR test is greater than the critical value, so the model target normal with the external factor is the best model. So we use this model. Okay, from this model we can see here. Here mean the length is significant fact the yield, the frontier 0.177 or 70%. Increasing the length 1% will affect the increase in yield 0.17%. Okay, and then for seed also significant. It means increasing 1% seed will impact 0.23% the yield. And then for the fertilizer, nitrogen fertilizer is not significant. Maybe in the field is already content high the nitrogen, so the given nitrogen no impact in the yield. And the phosphate also significant. Increasing 1% phosphate fertilizer will affect 0.1% the yield. And then the labor also significant. Increasing 1% labor will increase 0.2% the yield. And then the technical efficiency is affected by some factors. Education is significant effect in efficiency. So increasing the education so will reduce the inefficiency. So we can reverse. So increase education will increase the technical efficiency, and then the increasing experience will increase the technical efficiency. Because this is inefficiency, so we should read the reverse, and the edge is not influenced in the technical efficiency. And in here, the lambda is very big. It means that if the variation in the error is mainly caused by the inefficiency, not the error. The error of the little, but the inefficiency is major cause to the technical efficiency. Okay, and right now we can predict technical efficiency, then we can LMS. Okay, see here on the technical efficiency, the respondent one is 0.77 or 77%. Respondent 2 is 85%, and so on. And then we can see in the descriptive for summarize the TA, sum TA, for the 76 observation, the mean efficiency is 0.85 or 85%, and then standard deviation is 0.09, and then the minimum efficiency is 0.59 or 59%, and the maximum is 99%. Okay, thank you for your watching, and see you again.